Solving systems by elimination. My first equation in my system is 2x plus 3y equals 13. My second equation, which I'm going to stack right underneath it, so is negative 4x plus 2y equals negative 2. Now we look for additive inverses, and there are none. I have a positive 2x and a negative 4x. Those are additive inverses. I have a 3y and a 2y positive. Those are additive inverses. So I have to create my own additive inverses. Now, since there's a common multiple for 2 and 4, that is 4, I can use 4 as a common multiple, and I can keep this positive, and this will be negative, and I'll get additive inverses from these two. I can turn that into a 4x, I can keep this a negative 4x, and I'll have additive inverses. So let's do that. Let's multiply this by 2. And this will now be 4x plus 6y equals 26. And this down here remains negative 4x plus 2y equals negative 2. And now we have additive inverses right here. Positive 4x and negative 4x. With additive inverses, we can combine both equations where these will eliminate, and we'll end up with 8y equals 24. Now we'll solve for y by dividing both sides by 8. And we'll end up with y equals 3. So y is solved. Now for x, let's see, to solve for x, I'm going to use the first equation, which is 2x plus 3y equals 13. So 2x plus 3y equals 13, and I'm going to substitute the y here for 3. So this will become 2x plus 3 parentheses 3 equals 13, which will become 2x plus 9 equals 13. And solving for x, or to isolate x, we have to get rid of the 9. So I'll subtract 9 from both sides, and this will end up giving me a 2x equals 4. If I divide both sides by 2, we finally get that x equals 2. And so our solutions are x is 2 and y is 3. Okay, next system, we have a 3x plus 6y. Oops, it's a bad looking 6. Y equals negative 3. And we have a 4x minus 4y equals 20. Okay, now there are no additive inverses. That's a 3x, that's a 4x, this is a positive 6y, it's a negative 4y. So there are no additive inverses. But I can make additive inverses by finding common multiples, and definitely the least common multiple. So the least common multiple for 6 and 4 would be a 12. So I would want this to be a 12y and this to be a negative 12y, and then we'll have additive inverses. So to make this into a 12y, we have to multiply by 2. And to make this into a 12y, or negative 12y, we'll have to multiply by 3. Okay, so multiplying by 2 gives me 6x plus 12y equals negative 6. Multiplying this, or distributing a 3 across this, will give us 12x minus 12y equals 60. And now we have additive inverses, and we can combine these two equations together. So when we combine them, we'll get 18x's. These eliminate, and we'll get 54 here. Okay. Now I'm going to divide both sides by 18, and hopefully this will come out even. I think 18 goes into 54 3 times. So x equals 3. Okay. Alright, so next, we want to take one of the equations. Let's take the 3x plus 6y equals -3. And we will substitute our x for 3. So this will become 3 times 3 plus 6y equals -3. And 3 times 3 is 9 plus 6y equals -3. And now to isolate my x, I'm going to subtract 9 from both sides. And I'll end up with a 6y. So to isolate my y, I'll get 6y equals -12. So if I divide both sides by a 6, I'll end up with a 1y that equals -2. And those are my solutions. That x equals 3 and y is -2.